Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing. Never give up, never slow, till I finally prove it.
For our objectives, represent the absolute value of the number on a number line as the distance of a number from zero. Performs fundamental operations on integers. We have a pretest. Multiple choice. Write the letter of the correct answer on a sheet of paper. Number 1. What is the absolute value of 10? Letter A, 10. Letter B, negative 10. Letter C, 11. Letter D, negative 11. Number 2. When 9 is added to negative 15, what is the result? Letter A, 24. Letter B, negative 6. Letter C, positive 6. Letter D, negative 24. Number 3. What is 10 minus negative 9? Letter A, negative 19. Letter B, negative 1. Letter C, 1. Letter D, positive 19. Number 4. What is the product when negative 18 is multiplied by negative 2? Letter A, negative 16. Letter B, negative 20. Letter C, positive 36. Letter D, negative 36. Number 5. What is the quotient when positive 35 is divided by negative 7? Letter A, 28. Letter B, negative 28. Letter C, negative 5. Letter D, positive 5. We will now check your answers. We have number 1. What is the answer? Letter A. How about number 2? We have letter B. Number 3. We have letter D. Number 4. We have letter C. And for the last number, we have letter C. That is only a pretest. Absolute value. Absolute value is defined as the distance from the origin regardless of the sign. Absolute value or modulus. The absolute value or modulus of a real number x is its non-negative value or distance from zero. We need to find the absolute value of 2. That is the distance from 0 to 2. This is the symbol for absolute value. So the absolute value of 2 is 2. Next, we need to find the distance from 0 to negative 2. That is the absolute value of negative 2. This is the symbol for the absolute value of negative 2. So the absolute value of negative 2 is still 2. We disregard the sign. We need to find the distance from 0 to 1. The distance from 0 to 1 is the absolute value of 1, and the absolute value of 1 is 1. But in this particular number, we have this one. We read this one as the opposite of the absolute value of 1. So we have the absolute value of 1, and the opposite of 1 is negative 1. So that is our answer. We have the distance from 0 to negative 3. The distance from 0 to negative 3 that is going to the left, that is the absolute value of negative 3. And the absolute value of negative 3 is 3. We need to find the absolute value of the following. Number 1, the absolute value of 16. What is the answer? The answer is 16. Did you get it correct? Very good. Number 2, the absolute value of negative 16. What is the answer? The answer is still the same. Very good, class. You got it correct. Number 3, the opposite of the absolute value of 25 minus 5. First, we find the absolute value of 25 minus 5. Then after that, we get the opposite of your answer. What is the result? The result is negative 20. Let's clap our hands. The next number, number 4, the absolute value of negative 36. What is the answer? The answer is 36. Very good. For the last number, the opposite of the absolute value of 21 minus 11. What is the result? The result is negative 10. Congratulations. Very good for making it for our exercises. So we have integers. Integers includes the positive integers, the negative integers, and zero, also known as directed numbers. In other books, they use the word signed numbers. So we have our number line. This is 0. These are the positive integers to the right of 0. And we don't need to write positive. If a number doesn't have a sign, it is understood that the numbers are positive. To the left of 0, we have the negative integers. We have negative 1, negative 2, negative 3, negative 4. It means we have an arrow. It is extended to the right and to the left. So we have addition of integers having like sign. We use color yellow for positive, and we can make use of color red for negative. So we have the given figure. This is represented as positive 3 plus positive 2. And for the next figure, this is the representation for negative 1 plus negative 2. We are going to answer the first number. Positive 3 plus positive 2. We just count the number here. 1, 2, 3, 4, 5. So we have positive 5. We have negative 1 plus negative 2. 1, 2, 3. Therefore, the answer is negative 3. We are in the next figure. We have positive 2 plus positive 4. What is the result? The result is positive 6. How about for the next figure? We have negative 1 plus negative 3. What is the answer? The answer is negative 4. So how do we add integers having like sign? What have you noticed in our previous example? So we have, in adding two integers having like sign, just add the numbers and copy the sign. We have addition of integers having unlike sign. So what is this number? This is positive 4. And this one is negative 2. So we have positive 4 plus negative 2. Positive 4 plus negative 2. But look at this one. If we add 2 and we subtract 2, what is the result? The result is 0. This is 0. So therefore, positive 4 plus negative 2, what is the result? The result is positive 2. So we have the given figure. This is represented as negative 4, and this one is positive 1. So we have negative 4 plus positive 1. But if we try to add 1 minus 1, what is the result? The result is 0. Therefore, what is our answer? Our answer is negative 3. We have another problem. We have positive 3 plus negative 1. Positive 3 plus negative 1. And this is represented as 0. That is 1 minus 1, that is 0. Now, what is our result? Our result is positive 2. So how do we add integers having unlike sign? In adding two integers having unlike sign, subtract the numbers and copy the sign of the number with bigger absolute value. We are in subtraction of integers. We have negative 1 minus negative 2. The rule is to change the sign of the subtrahend. Our subtrahend is negative 2 and proceed to the process of addition. So it will become negative 1 plus positive 2. This negative 2 will become positive 2 and the operation subtraction will become addition. And we proceed to the process of addition of integers. We have 1 plus negative 1, that is 0. Therefore, what is the result? The result is positive 1. We are in the next example. We have positive 2 minus positive 4. So again, we'll change the sign of the subtrahend and proceed to the process of addition. It will become positive 2 plus negative 4. So, we have 2 plus negative 2 is 0. So, what is positive 2 plus negative 4? The result is negative 2. So, we have the next example. We have negative 1 minus negative 3. Change the sign of the subtrahend and proceed to addition. It will become negative 1 plus positive 3. What is 1 plus negative 1? 1 plus negative 1 is 0. Therefore, what is our result? Our result is positive 2. So, if we subtract integers, what are we going to do? We change the sign of the subtrahend and we proceed to the process of addition of integers. So how do we subtract integers? In subtracting integers, change the sign of the subtrahend and proceed to addition of integers. We are now in multiplication of integers. I want you to analyze the example. We multiply a positive by a positive, the result is positive. A positive by a positive, the result is positive. But if we multiply a positive by a negative, the result is negative. So, we have positive times positive equals positive. And we have the other one, positive times negative equals negative. So, we have the negative numbers. We need to multiply it by positive 2, positive 1, 0, negative 1, negative 2, and negative 3. So we have negative times positive is negative, and we have negative times negative is positive. So we have negative times positive is negative, and we have negative times negative is positive. So what is the product of two integers having like sign? The product is positive. Positive times positive is positive, and negative times negative is positive. So we have the product of two integers having unlike sign is negative. Positive times negative is negative, and negative times positive is negative. We are in division of integers. If we divide a positive by a positive, the result is positive. and a negative by a negative, the result is also positive. So, the quotient of two integers having like sign is positive. So, we divide a positive by a negative. Positive 20 divided by negative 4 is negative 5. Negative 35 divided by 5 is negative 7. So, if we have unlike sign, so we have the quotient of two integers having unlike sign. The quotient of two integers having unlike sign is negative. So we have division of integers. The quotient of two integers having like sign is positive. And the quotient of two integers having unlike sign is negative. So we have real life examples of integers. We have temperature is another way integers are shown in real life because the temperature is always either over 0 or below 0. We have the speed limit. When you're driving, you can go over or under the speed limit. We have the sea level, above and below sea level. Let's practice. Number 1, positive 24 plus negative 4. What is the result? The answer is positive 20 or 20. How about in number 2? Negative 25 plus negative 12. What is the answer? The answer is negative 37. For problem number 3, negative 25 divided by negative 5. What is the quotient of two integers having like sign? So the answer is positive 5 or 5. For number 4, we are using multiplication here. What is the product of two integers having unlike sign? The answer is negative 140. And for the last number, we are in subtraction. The rule in subtraction is to change the sign of the subtrahend and proceed to addition of integers. Therefore, the result is negative 2. We are now ready to answer the first test. Multiple choice. Write the letter of the correct answer on a sheet of paper. Number 1, positive 10 plus positive 12. Letter A, negative 22. Letter B, negative 2. Letter C, positive 2. Letter D, positive 22. Number 2, negative 10 plus negative 12. Letter A, negative 22. Letter B, negative 2. Letter C, positive 2. Letter D, positive 22. Number 3, negative 10 minus negative 12. Letter A, negative 22. Letter B, negative 2. Letter C, positive 2. Letter D, positive 22. Number 4, negative 18 times positive 2. Letter A, negative 36. Letter B, negative 9. Letter C, positive 9. Letter D, positive 26. Number 5, positive 18 divided by negative 2. Letter A, negative 36. Letter B, negative 9. Letter C, positive 9. Letter D, positive 36. So we have the answer for the post test. Number 1, letter D. Number 2, letter A. Number 3, letter C. Number 4, letter A. And for the last number, we have letter B. God made the integers, man made the rest, by Leopold Kronecker. Integers are the fountainhead of all mathematics. Thank you for watching.